Open your book to page 450. Today's lesson is on inverse variation. So last time we covered the direct variation. So the inverse variation means whatever after the word inverse, it will go into denominator. So let me give you an example. Okay, so when you have example 5, it says y varies inversely as x. Okay, so the way to translate is this. So y means y, varies means equal to k times something. Now when you see the word inversely, okay, that means everything after that goes on the denominator. So inversely as x, that means the x goes on the denominator. So it's very simple. Okay, again, when it says words, when you see the word varies, right away, that's a proportional problem. That means you're going to equal to k times something. But in this case, it says inverse. So everything after the word inverse goes on the bottom. Okay. After that, everything is exactly the same as what you did earlier. So it says if y equal to 6, when x equal to 2, so that's your clue. That's the information you need to find k. So you do the same thing as you did before. You substitute. So 6 equal to k over 2. So you can multiply by common denominator. Multiply both sides by 2. So this will cancel out. So k equal to 12. So that's your part A. So k equal to 12. Then B, you're looking for y when x equal to 3. So remember what I said, right? When you find k, the first thing you need to do is you need to update your equation. So y equal to 12 over x. So that's your equation. So now you can use the updated equation to solve the next part. So you're looking for y when x equal to 3. So y equal to 12 over 3. So y equal to 4. Okay, and that's part B. So it's same as the last lesson. It just, the only difference is when you see the word inversely, everything after that goes on the denominator. The k always on the top. K will never be on the bottom. Okay. Okay, so let's go over more example. Let's go to example 6. So again, let's go and translate. So it's y. So write down y. Is means equal. Inversely proportional. That means equal to k over something. Right? Inversely proportional to the square of x. To the square of x. So that's your equation. Then it says if y equal to negative 3, when x equal to 4, you're looking for k. So that's going to do that. Substitute everything in here. So negative 3. Whenever you substitute, put in the parentheses. Equal to k over 4 square. So negative 3 equal to k over 16. You cross multiply, or you can multiply by common denominator. So k equal to negative 48. So as soon as you find k, you update your equation. So y equal to negative 48 over x squared. Then, so you can use the updated equation to look for the next part. It says find y when x equal to negative 6. So you substitute. Now this is why it's so important to put in parentheses when you substitute, because of the negatives. Okay? If you don't put in parentheses, it's very likely you're going to make a mistake on the sign. So substitute. So y equal to negative 48 over 36. And you can reduce by 12. So y equal to negative 4 over 3. And that's your answer. Okay. So that's your B. Okay, let's go to example 7. So you do the same thing, you read the problem. It says, under certain conditions, the pressure P of the gas vary inversely, so K over something, inversely as the volume. Okay, so A, write the variation equation, so that's it. So that's your answer for A. Write your equation. Now it says if P equal to 30 and V equal to 500, you're looking for K. So you substitute all this in here, so you got 30 equal to K over 500. So cross multiply or multiply by common denominator. So you get 15 with 3 zeros. So that's your K. So that's part B. Then you go to part C. You update your equation. So P equal to 15,000 over V. So update your equation right away. Then after that, you can go ahead and do the next part. It says find P when V equal to 200. So you substitute. So P equal, then you can cancel all the zeros and then divide, so you get 75. And that's the answer for part C. And that's it. Okay? So again, nothing really new. Okay, you need to know what to do when it says inversely. Okay, so let's go and do some practice.